Section 3 in our matrix chapter deals with things called determinants and inverses. Determinants are a useful property of matrices. Unfortunately, in Algebra 2, we don't really get into how they're really useful, but at least you're going to learn how to do them by hand. This section is an introduction to determinants and includes how to solve them and a couple of the basic things you can use determinants for. They're kind of handy. Also, we're going to talk about inverses, but that's later on. To find the determinant of a 2 by 2 matrix, multiply the two diagonals and subtract them. So you're going to multiply A times D, and the way you're going to write this is, the way the book writes it is determinant A, B, C, D. Another way you could write this, the way that I learned how to do it and the way that most books actually do this, is just a bar instead of a bracket, A, B, C, D. This is the way I prefer to do it because now you don't have to write this and you don't have to make the little hooks on the end of your brackets. It's just nice straight lines. It's faster. So here's your determinant, and all you do is you multiply the diagonals. So A times D, and subtract that from C times B. Or B times C, I suppose. That's it. That's the determinant. Whatever number you get from this is the answer. The important point, every square matrix has a determinant. So it has to be square, 2 by 2, 3 by 3, 4 by 4, so on, okay? If it's not a square, then it does not have a determinant. So let's practice a little bit, evaluate each determinant. Notice I'm using the notation the book uses. You could also write it like this, 5, negative 4, 8, 9 with straight brackets rather than, kind of looks like absolute value brackets, but it's not absolute value. So we will do what? 5 times 9 is 45. Minus 8 times negative 4, which is negative 32. So we have 45 minus negative 32. Minus minus turns to plus. 45 plus 32 is 77. Notice I haven't taught you how to do this on the calculator yet. The calculator does do it for you. But look at how easy that is. It actually takes more time to enter it into the calculator than to just do this. So just do it. All right? Go ahead and try the other three. What do we have for an answer on this one? Negative 24. That's correct. And an answer on this one? Positive or negative? Negative 118? Because this is negative 48. We have negative 48 minus negative 70. Minus minus turns to plus, and it becomes 22. Remember, you're subtracting those numbers. How about the last one? Negative 28 minus 45, negative 73. My little public service announcement at the bottom of the page. The determinant for a 3 by 3 matrix can be found in two ways. The book's method, which I don't even know why they bother to teach it, honestly. I'm going to go on a little bit of a rant here. I hate it. This method can only be used for a 3 by 3. So learning the book's method prevents you from going on and expanding your knowledge to another dimension matrix. So I'll show it to you, but I'm not going to do it ever again. So if you want to use it, you can use it, but I'm not going to do it again. The expansion method is the other method. It's not in the book. It's way more powerful. It's way better. You get the answer correct every time for any dimension matrix, period. So that's why I prefer to teach you that. It's the way you should know how to do it. Later on, if you go on to higher levels of mathematics, you'll be using the expansion method in physics courses, in calculus courses, and so on. It's just better to know the expansion method, okay? So I'm showing you both methods because the diagonal method, the book's method, is in there, and I just want to show you how to do it. But I don't like it. It's the wooden sword. In fact, the wooden sword, it's not even wooden really, it's like rotten. It's the rotten stick that you found in the woods and you're using it to defend yourself. Terrible. Okay, the diagonal rule. Rewrite the first two columns to the right of the determinant. So here's my determinant sitting here. Here's my first two columns. I'm going to rewrite them to the right. So 4, negative 3, negative 4, negative 8, 2, 5. Okay, so now we've rewritten these two columns over here. What you're going to do is you're going to multiply diagonals and then add them together. So you're going to multiply this diagonal, all the numbers there together. Multiply this diagonal, all the numbers there together. And multiply this diagonal, all the numbers there together. And then you're going to add all those together. Once you're done with that, so you'll have a bunch of stuff here being multiplied out and added together. Once you're done with that, let me pick a really lovely color here. How about purple? You are going to subtract the other diagonals. The other diagonals start here. You'll multiply all those numbers together and add them to all of these numbers and add them to all of these numbers. And those will all go here, added together. When you're done, you'll have a number minus some other number. Do that subtraction, and that's it. You're done. No, I didn't say that.
And this is why you don't teach us this, right?
This is why I don't like this method. This gets it done, but if this was a 4x4 matrix, you wouldn't be able to do this method anymore. Okay? Okay, so let's go ahead and do this math. We have 4 times 2 times 9. 4 times 2 is 8. 8 times 9 is 72. Negative 8 times 6 times negative 4. Let's see, there's no easy way to do this one. Negative 8 times 6 is negative 48. Negative 48 times negative 4 would be positive 196. 176? 176. So positive 176. And then the third diagonal, 3 times negative 3 times 5. This is easier. 3 times negative 3 is negative 9. Negative 9 times 5 is negative 45. So I'm going to write negative 45. Now I'm going to do my other diagonals. So I'm over here now. Negative 4 times 2 times 3. 2 times 3 is 6. Times negative 4 is negative 24. What? 190. Negative 48 times negative 4. 2, 3. Yep. Thanks. Whoever told me 176 was terrible. I was closer with 196. Anyways, second diagonal. 5 times 6 times 4. A couple different ways you can go that easily. 5 times 6 is 30. 30 times 4 is 120. So plus 120. 9 times negative 3 times negative 8. A little bit tougher on this one. We have a negative times a negative, which is positive. So 3 times 8 is 24. 24 times 9. What am I? Thank you. What is it? 216. So now we add these two things together. We have 72 plus 192 minus 45. What is that? 19. 219. Minus negative 24 plus 120 plus 216. 312. 219 minus 312. Negative 93. So there's your answer. That's the determinant for that 3x3 matrix. Using the diagonal method, the wooden sword, the rotten, termite-infested, terrible, terrible thing. Okay, the expansion method is the better/real way to do these, the way that normal people do it. It's the adamantium sword. Indestructible perfection. First, choose the first element. Block out the row and column it's in. Multiply the element times the remaining 2x2 determinant. Piece of cake. Choose the second element. Again, block out the row and column, multiply the elements times the remaining 2 by 2 determinant. Piece of cake. Same thing for number 3. This is what this means. You're going to go across the top row. You're going to choose the first element in that row. You're going to block out that row and that column. And once I do that, notice what's left. It's a 2 by 2 matrix. I'm going to find the determinant of that 2 by 2 matrix. So what I have is this element right here, A, times the determinant of the 2 by 2 matrix, E, F, H, I. Not done. I got to do that again. But I'm moving across. Instead of circling A, now I'm circling B. And since B is in the second column, I'm going to block out the second column. And since B is in the first row, I'm going to block out the first row. And once I do that, I'm left with a 2 by 2 determinant. Now this time it's going to be minus. It says subtract for step 2 here. So minus the element B times the 2 by 2 determinant D, F, G, I. Now step 3, choose the third element, and it says add, so it's going to be a plus here. We are going to use which element this time? C. And we're going to block out the first row, the third column, and you can see a 2 by 2 determinant sitting there, so what will I have here? First will be C, line, D, E, G, H, line. Okay? Now, you have 3 2 by 2 determinants, which we just blew through in like 41 seconds, like 5 minutes ago. These are easy, easy, easy. Find the determinant, multiply that times that number. Find the determinant, multiply it by that number. Find the determinant, multiply by that number. Take care of that addition, and you're done. It's way easier, actually, than the diagonal method. You'll see how it works here in 6 seconds.
So you can't like thank you. That word, the A.
No, you can't.
Okay.
Just leave it. Do the determinant. It'll be easier to just let it be. Do the determinant, multiply. Okay, so let's do this. We have first element here. Block out, and you don't have to actually do that on your paper. It'll just make it messy, but just visualize yourself blocking out. And now I have this 2 by 2 determinant here. So I'm going to write 4. Okay, we're expanding this 3 by 3 into 3 2 by 2 determinants. Then what's going to be next? Yeah, remember it's minus. And that's a negative 8. So we'll actually turn into plus 8. And then my determinant will be, okay, and then next will be plus. Let me get rid of this, draw in my new, keeping the 3, block those out. So it's going to be what? Okay, still have time. We've expanded it, now we're just going to simplify. So we have that 4 sitting out front still. The determinant turns into 2 times 9, which is 18, minus 5 times 6, which is 30, plus 8 times, negative 3 times 9 is negative 27, minus negative 24, so plus 24, plus 3 times, negative 3 times 5 is negative 15, minus negative 4 times 2 is negative 8, so plus 8. I'm just being very formal. I'm writing everything down. 4 times negative 12 plus 8 times negative 3 plus 3 times negative 7. This is negative 48 minus 24 minus 21. Negative 48 minus 24 is negative 72. Minus 21 is negative 93. Was this exactly the same problem as the last one that we did?
Yeah, a lot faster.
Yeah, a lot faster, a lot easier, a lot better. So I would prefer using the expansion method.